Now, the reactivity of sodium metal with water. Sodium metal is a very reactive metal, and for that reason has to be kept stored under glass, and also has to be covered with an oil. In this particular case, this is a light mineral oil that is covering this. Sodium metal is fairly soft. I'll cut a piece of it to use in the demonstration and put the rest of the metal back into the container. Note that I do not have a tremendously large piece of sodium metal, but I will now place that sodium metal into the beaker and we will watch the reaction that occurs into the beaker. There we go. There is phenolphthalein in the beaker. You'll notice the pink to purple color forming. That indicates that we have a basic solution forming. Note how the sodium metal sort of skims over the surface. That is an exothermic reaction. Sometimes it will burst into flame. In this particular case, it did not. That was a reaction of a relatively small piece of sodium metal with water, producing hydrogen gas and a basic solution as shown by the indicator of sodium hydroxide. Let's now examine the reaction of potassium metal with water. Potassium is in the same group with the sodium hydroxide, and I have here a piece of potassium metal that is coated with a relatively heavy layer of mineral oil. Put this extra piece back into the container and move the container out of the way. And now, to finish dabbing off the oil, we will drop, this will be pretty good, the piece of potassium metal into the beaker. As you can see, the reaction is much more violent, and I don't know whether you heard that or not, but I heard the noise come out. You note again that the solution has turned purple, indicating the formation of a basic solution. In this case, it is a solution of potassium hydroxide, as shown by the phenolphthalein color. There we have the reactions of sodium metal and potassium metal with water. This is a demonstration of part 2 of the experiment entitled Group and Period Relationships Reactivity. The second part of the experiment is entitled The Halogens and Their Reactivity. Reading from the directions, it says, place 20 drops of carbon tetrachloride, CCl4, in each of 3 15-centimeter test tubes. You'll notice that the carbon tetrachloride has already been placed in the 3 test tubes as shown. It says to one test tube add 5 milliliters of chlorine water. Chlorine water is a solution of chlorine in water. To another add 5 milliliters of bromine water. This is a solution of Br2 in water. And to another 5 milliliters add iodine solution, which is a solution of I2 in water. Stopper and shake each test tube. Observe the color of each free halogen. We have in the first test tube chlorine in carbon tetrachloride. In the second test tube we have bromine in carbon tetrachloride. And in the third test tube we have iodine in carbon tetrachloride. Reading from the instruction sheet again, it says the free halogens, chlorine, bromine, and iodine, have a much greater solubility in CCl4 than in water. The free halogens are therefore extracted into the carbon tetrachloride. Carbon tetrachloride is heavier than water. Use this information to identify the free halogen in the following experiments. You'll notice when I pick up the bromine in carbon tetrachloride solution that there are 2 distinct layers. You have the lower layer, which has a reddish-orange color, and the upper layer, which is essentially colorless. Since carbon tetrachloride is heavier than water, obviously the carbon tetrachloride is on the bottom and the water is on top. Let's now examine the colors of these 3. The first one, where we had the chlorine in water, is a light green. The second one, where we had the bromine in water, it is a reddish orange. And the third one, where we had the iodine in water, it is a violet color. Let's look more closely at these colors. The light green of chlorine. Now remember, the chlorine has been extracted into the carbon tetrachloride layer, into the bottom layer. The light green is indeed very faint, but I think you can pick up the light green color. Then we go to the bromine. The bromine again has been extracted into the bottom layer, the carbon tetrachloride layer, and it is a reddish orange color. And finally, we have the violet color due to iodine. It is in the lower carbon tetrachloride layer. These 3 colors that we have examined here are characteristic of the free halogens. Chlorine in carbon tetrachloride is always a light green color. Bromine is always a reddish orange color in carbon tetrachloride, and iodine is always a violet color in carbon tetrachloride. In part B of the experiment, the instructions read, add 20 drops of chlorine water to 2 milliliters of 0.1 molar potassium bromide solution in a 15-centimeter test tube. Then it says add 20 drops of carbon tetrachloride, stopper and shake to extract the free halogen from the water solution. A question is asked, what is the color of the carbon tetrachloride layer? Which halogen is present as the free element? And when you read on, if it is chlorine, then no reaction has occurred. If it is bromine, then chlorine is more reactive and has displaced the bromine from the KBr solution. The directions also say to add 20 drops of chlorine water to 2 milliliters of 0.1 molar Ki solution, followed by 20 drops of carbon tetrachloride, all in a 15 centimeter test tube. It then says compare the reactivity of chlorine with iodine as before. You'll note we have two test tubes. The test tube on the left contains a solution of potassium bromide. The test tube on the right contains a solution of potassium iodide. I'll now add to each of these solutions 2 milliliters of chlorine water. And then I will add to those two solutions a milliliter of carbon tetrachloride, which is the same thing as 20 drops. As the last step in this experiment, we stopper the test tubes and shake. The first tube is the one that originally contained potassium bromide, to which I added chlorine water. And the second test tube originally contained potassium iodide, to which I added chlorine water. Now let's examine the colors. We have to keep in mind that sometimes concentrations do not always come out the same, so the intensity of the color may indeed be deeper. In the first test tube, where we put the chlorine into the potassium bromide, we note that the color of the lower level of solution, the carbon tetrachloride level, is a reddish orange. From our experiment earlier, we know that reddish orange corresponds to free bromine. Examining once again what we did, we put free chlorine into potassium bromide. We now have free bromine in the carbon tetrachloride layer, so we can conclude that a reaction has indeed occurred. In the second reaction, where we had chlorine placed into the potassium iodide, we observe that the color is indeed very, very deep. It is a very deep purple, indicating a tremendous amount of iodine has been released from that solution when chlorine water was placed into potassium iodide. That deep violet color indicates the presence of free iodine. So chlorine has reacted, freeing iodine. We now move to part 2C of the experiment, which reads, now test the reactivity of bromine by adding 20 drops of bromine water to 0.1 molar solutions of KCl and Ki in separate 15 centimeter test tubes. Use carbon tetrachloride as before to help you decide whether a reaction has occurred. Be certain to stopper the test tube before shaking. Likewise, test the reactivity of iodine with 0.1 molar KCl and KBr solutions. That, of course, is part D. Displayed now are two solutions. The first solution is potassium chloride in water, and the second solution is potassium iodide in water. I will now add 2 milliliters of bromine water to each of these solutions. That's bromine in potassium chloride. And now we put bromine into the potassium iodide. And so we can tell whether or not a reaction has occurred. We will add about a milliliter of carbon tetrachloride to each of these solutions. And as before, we stopper the test tubes and shake. This is bromine water added to potassium chloride, and bromine water added to potassium iodide. The color in the first reaction is reddish orange, as we can see by examining the lower level, the carbon tetrachloride layer in the test tube. That is reddish orange, which we know corresponds to bromine. Since we put free bromine in, and we still have free bromine, what can we conclude about the reactivity of bromine as compared to chlorine? In the second test tube, we examine the color, and we note that the color in the carbon tetrachloride layer is a violet color. We added free bromine, but now in the carbon tetrachloride layer we notice the violet color that corresponds to free iodine. So what can we conclude about the occurrence of a chemical reaction? When we added bromine to potassium chloride, we got a reddish orange carbon tetrachloride layer. When we added bromine to potassium iodide, we got a violet carbon tetrachloride layer. As we read a few moments ago in part 2D, it says, likewise test the reactivity of iodine with 0.1 molar KCl and 0.1 molar potassium bromide solutions. Well, we'll do the same thing we did before, except now you'll notice on the table we have a solution of potassium chloride on the left and a solution of potassium bromide on the right. To each of these solutions I am going to add 2 milliliters of iodine water, which of course is iodine, free iodine, dissolved in water. Iodine added to potassium chloride, and now we add 2 milliliters of iodine water to potassium bromide. To find out whether or not a reaction has occurred, we now put in about 1 milliliter of carbon tetrachloride. Followed by stoppering of the test tubes and shaking. This first one corresponds to iodine water placed into a solution of potassium chloride. The second one corresponds to iodine water placed into a solution of potassium bromide. And we have, of course, put the carbon tetrachloride in, and the carbon tetrachloride is being extracted into the lower layer. And we note that in each case the violet color of iodine is present. Here we have the solution of potassium chloride to which we added iodine water. The carbon tetrachloride layer is violet color corresponding to free iodine. In the second case, we added iodine water to a solution of potassium bromide. Once again, in the lower carbon tetrachloride layer, we have the violet color of iodine. So from that, we can conclude something concerning the reactivity of iodine with potassium chloride and the reactivity of iodine with potassium bromide.
pour just like a